Welcome to the session on algebra. In this session, we're going to be looking at equations. The objectives for this session are to turn statements into equations, be familiar with numbers, letters and symbols, and algebraic terms, shorthand and conventions, understand the BODMAS rules, change the subject of an equation, and solve an equation numerically or in terms of another unknown. Which letters should we use to represent numbers? In a real situation where the letters represent the value of something known, choose letters reminding us of that thing. So for example, let C equal the number of cats my neighbour has. So in this example, we have 3 cats, and therefore C equals 3. Let's now take a look at a more involved example. Suppose that the only pets my neighbour owns are cats or dogs. Let C equal the number of cats my neighbour has, and let D equal the number of dogs my neighbour has. Then the total number of pets, P, my neighbour has, is given by P equals C plus D, so the number of cats plus the number of dogs. If C equals 3 and D equals 4, then P equals 3 plus 4. So P equals 7. The language of algebra can be illustrated by using this example shown on your screen. The letters represent numbers. Remember that the letters could be fixed or variable, but usually, as we mentioned earlier, X, Y and Z will represent variables. Notice that there are no multiplication or division signs in this equation. This is because multiplication is represented by putting the number next to the letter or letters. So 3 times x equals 3x. Furthermore, numbers are placed before the letters. This means that if we have y times 5, we would write this as 5y. And letters are positioned in alphabetical order. So if we had 25 times z times x times y, we would write this as 25xyz. An algebraic term is a small group of numbers and letters with no symbols, as shown here. An algebraic expression does not have an equal sign, as shown here and here. And an algebraic equation does have an equal sign, as shown here. We're now going to take a look at some statements. Try turning them into equations. Have a go at statement 1. And now for statement 2. And now for statement 3. How did you find these? Let's now take a look at the first statement. It says, the number of students in the second year, S, is the same as the number of students in the third year, T. So we have S equals T. What about statement 2? The number of girls, G, in a class is 4 times the number of boys, B. So we have G equals 4B, or 4 times B. And now for statement 3. The area of my neighbour's garden, N, is twice as big as the area of my garden, M. This would be expressed as N equals 2M. Let's now take a look at some examples of selecting letters for variables. Which letter do I use to represent a variable? The number of teddy bears can be expressed as T. The number of dolls can be expressed as D. And the number of children in a class can be expressed as C. Before moving on, let's remind ourselves of the BODMAS rules. BODMAS is a useful acronym which informs us which mathematical operation should be performed first. First, we carry out the operations inside the brackets. Then, we carry out the orders or powers. Then, division. Then, multiplication. Then, addition. And finally, subtraction. Let's now take a look at creating equations. Suppose that this week I have brought pens and notepads for my students and recorded the total spent. Express this as an equation. So let's solve this. The total spent equals the cost of a pen times the number of pens plus the cost of a notepad times the number of notepads. Let T equal total spent. Let P equal cost of a pen. Let R equal number of pens. Let N equal cost of a notepad. And let S equal the number of notepads. We can now turn this into an equation. So we have T, the total spent, equals P, the cost of a pen, times R, the number of pens, plus N, the cost of a notepad, times S, the number of notepads. Let's now extend this example to find unknowns. Let's now use the equation we found in example 1 to find the total spent for this week if I bought 15 pens for £0.50 each and 18 notepads for £1.25 each. Let's solve this. Remember our equation was T equals PR plus NS, where T was the total spent, P was the cost of a pen, R was the number of pens, N was the cost of a notepad, and S was the number of notepads. So, plugging the values that we have in example 2 into this equation, we obtain T equals £0.50, the cost of a pen, times 15, the number of pens, plus £1.25, which is the cost of a notepad, times 18, which is the number of notepads. This gives us £7.50 plus £22.50, which is equal to £30. Let's now take a look at changing the subject of an equation. We're going to take a look at this example. In this example, we have the equation T equals PR plus NS. Here, T is the subject of the equation. We're going to alter this equation so that you can solve it for P. So let's solve this. To solve for P, we must first isolate the term with P in it. Since we have T equals PR plus NS, we need to isolate PR first. To do this, we need to subtract NS from both sides to give T minus NS equals PR. And finally, divide both sides by R to give t minus ns over r equals p. Let's now use this rearranged formula in this example. Remember we had the equation t equals pr plus ns, and then we changed it to make p the subject of the equation. In this example, we're going to find the price of a pen if the total amount I spend is £21.75. We also suppose that I have bought 12 pens and that I have bought 15 notepads for £1.25 each. So let's solve this. To find P, the price of a pen, we use the formula in the rearranged form. P equals T minus NS over R. And we plug in all the values into this formula. So altogether, I've spent £21.75. I've bought 15 notepads for £1.25 each, and I've bought 12 pens altogether. This gives me £3 over 12, which is equal to £0.25, which means the price of a pen is £0.25. Now let's take a look at a few general rules to solve equations. Firstly, we need to get rid of any fractions involving the unknown. Then multiply out the brackets, and then put all the terms involving the required unknown on one side of the equation. And finally, factorize and divide by any remaining coefficient to solve. Let's take a look at an example. If we're required to solve this equation for x, then we begin by multiplying out by 15, as we want to get rid of any fractions which involve the unknown, and 15, or multiplying out by 15, will do the trick, as shown here. This tidies up to this expression: 45 plus 21x equals 120 plus x, and notice that all the fractions have now disappeared. Next, we multiply out any brackets, but as there are no brackets, we don't need to worry about this step. Now we put all the terms involving the required unknown on one side of the equation. In this equation, we subtract x from one side to do just that. So we have 45 plus 21x minus x equals 120. In order to get the constant on the other side, we subtract 45 from both sides to get rid of this 45 on the left-hand side. So we now have 20x equals 75. And finally, we factorize and divide by any remaining coefficient in order to solve. So in this case, we have to divide by 20 on both sides to give us x equals 3.75. Now let's see how we can solve an equation in terms of another unknown. Let's take a look at an example. We're required to solve this equation for x. First, let's get rid of any fractions involving the unknown. Since this doesn't apply to this example, we need to worry about this step. Next, multiply out the brackets. So this does apply to this example, and we have 6 plus 7y equals 5x plus 10. We've multiplied out 5 times x plus 2. Next, we put all the terms involving the required unknown on one side of the equation. So we need to subtract 10 from both sides to give us 6 plus 7y minus 10 equals 5x. Next, we tidy up to give minus 4 plus 7y equals 5x. And finally, we factorize and divide by any remaining coefficient to solve. So of course we need to divide by 5 since we need to isolate the x on the right hand side. And we have x equals minus 4 plus 7y divided by 5, which can of course be written as 7y minus 4 divided by 5. This brings us to the end of this session. If you have understood its contents, you should be able to turn statements into equations, be familiar with numbers, letters and symbols, and algebraic terms, shorthand and conventions, understand the BODMAS rules, change the subject of an equation, and solve an equation numerically or in terms of another unknown. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.